Hi, this is Thomas. Welcome back. Our topic is binomial expansion. This is example 4. Our expression reads 4 minus 5x over quantity 1 plus x times quantity 2 minus x. Our requirements are decompose the expression into partial fractions and show that the cubic approximation of the expression is 2 minus 7 over 2x plus 11 over 4x squared minus 25 over 8x cubed. Now before beginning with the binomial expansion algorithm, I need to observe that the term I'm dealing with has a product of binomial expressions in the denominator. What this means is we need to perform partial fraction decomposition on this expression before we proceed with binomial expansion. This is an example of our case 1 scenario of binomial expansion. So what I'm going to do is I'm going to split 4 minus 5x over 1 plus x times 2 minus x into two fractions. First, numerator a over 1 plus x plus numerator b over 2 minus x. Now you might want to work through this partial fractions analysis for practice. What I'm going to do is move right to the end of the partial fractions analysis. We will have 3 over 1 plus x minus 2 over 2 minus x. Before moving on, one slight adjustment I'll make is that rather than an equation, we have an identity. So I'm going to show that the expression on the left is an identity with the expression on the right. We've solved for a and b to get the right side of the identity, 3 over 1 plus x minus 2 over 2 minus x. And now going back outside of the identity, back to our expression, we've split our original expression into two fractions. And so now to set up our analysis for binomial expansion, our first term is 3 times 1 plus x to the power of negative 1 minus 2 times 2 minus x to the power of negative 1. Now we see we have two binomial terms. We'll apply binomial expansion to both terms, combine like terms to show that the cubic approximation of our analysis does match that given in requirement 2. And now moving to the binomial expansion algorithm. Step 1, identify n term and x term. So we'll begin by working with the first binomial, 3 times 1 plus x to the power of negative 1. Our n term is negative 1, and our x term is x. And I will label this as step 1. Step 2, substitute in n term and x term. We're multiplying everything by 3, so we have 3 open bracket. Now our binomial expansion, first term is 1 plus n times x, which in this case is negative 1 times the x term of x, plus in the denominator 2 factorial, in the numerator n times n minus 1, which is negative 1 times negative 1 minus 1, multiplied by the x term to the power of 2, x to the power of 2, plus our final term in the denominator 3 factorial, in the numerator n times n minus 1 times n minus 2, negative 1 times negative 1 minus 1 times negative 1 minus 2, all multiplied by the x term to the power of 3, x to the power of 3. Close bracket. This completes step 2 as well as step 3. Moving on to step 4, simplify terms. Still multiplying by 3, 3 open bracket. 1 plus negative 1 times x is minus x, plus negative 1 times negative 1 minus 1, which is negative 1 times negative 2, which is 2 over 2 factorial. 2 over 2 times 1 will be 1. So we have plus 1 times x squared. Next, in the numerator, negative 1 times negative 1 minus 1 times negative 1 minus 2 is negative 1 times negative 2 times negative 3. Thus, minus, the numerator will be 6. The denominator, 3 factorial, 3 times 2 times 1, is also 6. So we have negative 6 divided by 6, which is 1, times x to the power of 3. Close brackets. And our final simplification, 3 minus 3x plus 3x squared minus 3x cubed, along with notation to show that this is an approximation of an infinite series. We'll complete step 5 of the algorithm after completing the expansion of the second binomial term and then combining both expansions. So I'll summarize our work on the first binomial term, and now we'll move on to our second term, and we'll perform that analysis in the next video.